So we're on 6-1, 6-1, and I'm going to do 24. In that handout, the little box at the bottom, that's what we're going to be utilizing to do these problems. So it's y to the 2n times y to the 4n plus 1. So the bases are saying you're multiplying, right? So what do you do with the exponents? Add the exponents. So it's 2n plus the exponent 4n plus 1. I technically don't need those brackets, so it's really 2n plus 4n plus 1. So it's y to the 6n plus 1, right? All right. Now, 28 says y to the 2n minus 1 to the third. Now what do we do with the exponents there? Multiply the 3 times the, so it's y 2n minus 1, and you multiply the 3, right? It's in that handout, in that little box, it's the use of the it's a first row, second column. That's application of that particular thing. So then what you have is y to the, distributing the 3 through there, 6n minus 3. So there's what they're looking for. Here's what they're looking for here. 32 is saying x squared z to the 4th 2xy z to the 4th a negative 3x cubed negative 3x cubed y squared. So you can drop those brackets, x squared c4, and they're all times each other. Times 2 times x times y times z to the 4th. And then this is a minus 3, better put a bracket around it. X squared y squared. This is a times this, times. Now, when I'm going to do this kind of one time, I'm going to get all the constants together. So it's 2 times a minus 3. And then get all the x's. X squared, x understood to be the first, times x squared. Then it's y. Okay, I better cross these off. The constants were these. The x's, this one, this one, this one. Right? Now it's the y's. So it's a y the first, and then times y squared. So I've gotten this one, and then it's times z to the 4th. So I've got this one. Everyone good with it? I think I got it up there right?
This means x to the 3rd.
Okay, I had this x squared, that x.
Okay, I see it.
And then, was this an x? I missed this, I changed that 3 into 2.
Yeah.
Thanks. This was supposed to be a 3. Oh, shit.
Yeah, and there's a Z4. The first Z4.
Yeah, right here is a Z4. Oh, and then there's
Another one.
another one. Okay. Thanks. Now I have them all down there? Okay.
Yeah.
Now what we're going to do, we'll multiply the, what I would just as soon do, have you do, is leave this in prime number in terms of these. I would just as soon have you do minus 2 times 3. And it'll become clear later on, is it's easier to cancel, factor and cancel problems as long as they're prime numbers. Then this is x to the 2 plus 1 plus 3. Because these bases are multiplied. Then it's y to the 1 plus 2. These two are multiplied. So you add the exponents. Then it's z to the 4 plus 4. Okay? I'm going to leave this prime factor, and then I'm going to add these. This is going to be x to the 6th, y to the 3rd, z to the 8th. Now, your answer sheet probably would say minus 6. I would just as soon have you leave it prime factor. 2 times 3. All right, the next problem. 38. This is 4ab squared minus 2ab squared c cubed cubed. So this first bracketed item, we got to clear that power out. So what we want to do is we want to go 4, and that we have to square it. Now technically, if I want to prime factor it, I would write it as 2 squared. I'm going to go 4 squared, a, and it's 2 times 1, isn't it? It's a to the first times 2, b to the first times 2. Now, these are all times each other. Now it's just times, and I got to go minus 2, and it's 2 minus 2 to the first times 3. That 3 right up there. A to the 1 times 3, b squared times 3, and c cubed times 3. Right? You see it? In this case, I've taken that 3 through here. There, 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 and there. I've taken that 3 through. In this case right here, I've taken the 2 through, and I've done it here. All right. Now, technically, this is what I would sooner have you do. Rather than having that 4, I'd rather have you do 2 squared times 2, so that this, when you ultimately get to it down here, you have 2 to the 4th. Then you put this one together with this one, so it's a minus 2 to the 3rd. Now you get all of your a's together. A squared, and then you bring your a third over. A this is going to be b squared, and you bring this b to the what? 6th. Then you bring c, and it's to the 9th. Do you see that? If you don't, I'll add a step right in here. I'll write this as 2 squared squared a squared b squared times a minus 2 to the third b to the third times b to the 6th times c to the 9th. You see what I take this one, that a squared, I take that one and that one, I get these two, right, next to each other. When I take this one and this one, I get these two next to each other. And when I take this one, I get that. Now then, this is a to the 2 plus 3, b to the 2 plus 6, and c to the 4th. Because when you multiply the bases, you add the exponents.
Why is it c to the 4th?
C to the 9th, okay. Because I looked at that and I saw a 4 rather than a 9. Can't read my writing. Now I want to go back and deal with this right here. Because I want it in prime numbers. And I want this as 2 to the 4th times a minus 1 to the 3rd. Didn't leave myself enough room. I'm going to take this right here, and I'm going to go over here and deal with it. I'm going to go 2 to the 4th, then I want it times a minus 1 times 2 raised to the 3rd power. 2 to the 4th times a minus 1 to the 3rd times 2 to the 3rd. This minus 1 right here to the 3rd makes this whole number a negative. Then I go 2 to the 4th power plus 3. This is 2 to the 7th. So what I write is a negative 2 to the 7th here. Then it's expressed in prime numbers. If it worries you, then take this number right here, multiply it by this number right here, and you'll get a negative 128. And negative 128 is the same as 2 to the 7th power. Because 2 times 2 is 4, 2 times 4 is 8, 2 times 8 is 16, 2 times 16 is 32, 2 times 32 is 64, and 2 times 64 is 128. That's 2 to the 7th power. And it's better to express it as 2 to the 7th power than it is to express it as 128. Because then if we had in the denominator a 2 to the 3rd power, which would be 8, rather than dividing 8 into 128, you'd simply subtract the 3 from the 7, and you get 2 to the 4th. Just easier to do. Quicker. Does that make sense? Yeah. Now, getting to the final answer here, minus 2 to the 7th. This is a to the 5th, b to the 8th. And there's our answer that we're looking for. That makes sense?
What about the C?
Did I forget the c? C to the 9th. Thank you, Karen. All right. Now we'll go down and look at 40. 40, now notice it says simplify. And what they mean by simplify is write it with a positive exponent. So 2 to the minus 3. If you wrote that with a positive exponent and you used your rule of, let me see, where did you do it? The second row, third column, notice it says that if you want to have positive exponents, you move it to the, if it's in the numerator, go denominator. If it's denominator, go numerator. This is in the numerator, so you'd write this as 1 over 2 to the third. And that's what they're looking for. Just simplify means write it as positive exponent. 42, notice, says what? It says 1 over x to the minus 4. So what are you going to do? Numerator with the positive exponent. Now, what this is getting at is this. If for convenience in a problem, you need to move things, you can simply move it from denominator to numerator and change the sign of the exponent. Or numerator and denominator and change the sign of the exponent. Okay? If I had something like this, if I had x to the 4th in the denominator and I had an x to the 6th up here, I could write this as x to the 6th times x to the minus 4 and then go 6 minus 4 is x squared, right? Because why? It's convenient to solve the problem, to move it. So anytime you want to move anything from one position to the other, you just change the sign of the exponent and you can move it. And then you can use your rules of exponents. And generally when the problems get more and more difficult, what you'll do is you'll move everything to the numerator with bases, and then you put like bases together and add the exponents. And then when you get done, then you'll simplify by making all positive exponents. 46. It says x cubed plus minus 2. So how am I going to do the simplification? Y over x cubed, right? Says the quantity 2x to the 0th power over a negative 2 to the 3rd power. What is that going to be? What is this? Any number raised to the 0th power according to second row, third column, third row, first column. What is it? 1, right? So that is 1, and the denominator is a minus in prime factored form 2 to the 3rd. Now I want to take this opportunity on this particular problem to show you something, if I haven't showed you before. If I have negative 2 and I go squared, and I have a negative 2 squared this way. Are both of those the same number? How many say they are? How many say they aren't? They're not the same number. Because this one says this. It says opposite sign of 2 squared. This one says square minus 2. What's the square of minus 2? 4. This says opposite the square of 2. So this one is minus 4, this one is 4. Does that make sense? It makes no difference when you're odd powering things, because then it's always negative, right? But when you're even powering things, you better make sure that it is bracketed or not bracketed. That's what I'm trying to show you. Okay, thanks. 58. So here's a to the minus 1, b to the minus 3, over a to the 4th, b to the minus 5. Now, these are all numbers that are multiplied or divided. So it makes no difference what order we do it in, right? We can do any order. We can multiply numbers together first and then divide. We can divide numbers and then multiply. We can alternate. We could take this number right here, a to the first, in the new minus 1 in the numerator, and we can take this one in the denominator, a to the minus 4, right? And then I could take the numerator one, the b to the minus 3, and I could put it times b to the plus 5. Do you see what I've just done? I've gotten everything in the numerator, right? By properly taking the denominators and changing their signs and moving them up. And now I got all the bases side by side. See what I've done? Now then, what can I do? I can take the a base and add the exponents. I'm adding minus 1 and minus 4, right? And I can take the b base and add the exponents. I can simplify that by going a to the minus 5, b to the plus 2, and now get all positive exponents and do what? B squared in the numerator, a5 in the denominator. It makes the process real easy. Just take everything to the numerator, change your exponents properly, combine them as multiplication by adding, simplify the addition, and then get everything with positive exponents. See, well, the process becomes real simple when you take it that way. And difficult problems can become quite easy. (62) a to the minus 2, y, this whole thing squared, x, y to the minus 2. What do you think we ought to do first? Do you think we should take care of those two things? And what would you do with those in terms of what their powers are? Multiplying by the exponents in which they're bracketed, right? So you'd go this x to the minus 2 that's inside there, and you multiply it by that exponent 2. Is that right? Then you'd go the y to the first, and you'd multiply it by the 2, right? Then you take your second bracketed term and you would take that x to the first that's inside the bracket and multiply it by -2, right? And then you take that y to the first and multiply it by a -2. Correct? We're good? So then this is x to the -4 y squared, x to the -2 y to the -2. Now, do we have to put our x's next to each other? No, they're all products, so what can we do? We can just go x to this fourth, -4, right? And then what will we do? Bring that -2 over, right? Plus a -2, so it's a -2. And I've taken care of these two items, correct? Is that right? Then I just do, now I'm ready to do my y's, and I do this term right here, 2, and I do this term, -2. Adding a -2 is 2 minus 2. And so I've taken care of that one and that one. Good. Now I'm ready to combine my exponent. This is going to be x to the what power? -6. Okay. Y to the two minus 2. 2 minus 2 is what? 0, right? So, this x to the -6 says, what are we going to do with it? To get positive exponent, we're going to do what? Take it in the denominator with a positive sign, right? And the y to the 0th is any number to the 0th power. Row 3, column 1 says what? It's 1. So there's my answer. Okay? Does it make sense? You see what I did is I expanded, moved everything in the numerator, combined the terms, then simplified the thing at the end. If you do that process, it makes solving the thing a lot easier. And, bigger problems, with the experience I have, I would have difficulty looking at some big problems and saying, oh, this is the answer, without working through and manipulating the problem. Okay. So let's look at 66 and let's decide what we're going to do with that. We have x to the 17th, y to the 5th, over a negative x to the 7th, y to the 10th. How do you want to proceed? You think you can figure out the sign of the problem, the end sign of the problem. Numerator is positive, the bottom's negative, so what's it going to be? The solution is going to be a negative with something in the numerator and something in the denominator, isn't it? Now, if we take everything to the numerator, we have an x, 17, and what would you come up from the denominator to put it side by side? An x to the, and which kind of 7? Negative 7, right? Because it's positive 7 in the denominator, going up, it's going to be negative. Then it's y to the 5th, and you're going to do what? You're going to bring up that y10, so what's it going to be? Y to the minus 10. 10. So now it's going to be a negative x. Do we have to put the 17 minus 7, or can we just write 10, right? y to the negative 5, right? And I'll be writing it in simple form. We're going to have what? X 10 in the numerator and y 5 in the denominator. Now, as you go along, you're going to look at this and you're going to say numerator is plus, denominator is a plus. When I go up, I'm going to go 7, so you just go right down to here and you write that. You'll say, here I got a positive 5, I got a positive 10. I'm going to have to go to the denominator and have a positive 5. But this problem here, you might be able to do it, but a problem like 70, you might not be able to do it that quickly, right? You'll have to do some manipulation first. So 70 says we got a minus 12 a squared b cubed over 9 a 5 b 9, and that's raised to the third power. Now here's where it's beneficial to prime factor your constant terms and do this. If you did a minus 1 times 2 squared times 3, is that 12? Is that minus 12? Minus 12 is a minus 1 times 2 squared, which is 4, times 3. 4 times 3 is 12. Okay? Then it's a squared b cubed, and the 9 in the denominator is 3 squared. Now then, this 3 I'm going to run through there. So that 3 says that minus 1 is to what? Third power, right? Minus 1 is 3. Then it's 2 to the 2 times 3 times 3 to the 1 times 3 a to the 2 times 3 b to the 3 times 3. That's the numerator, correct? The denominator is going to be 3 to the 2 times 3 a to the 5 times 3 b to the 9 times 3 b to the 9 times 3. Right? Now at this point, that minus 1 to the third power, we can figure out what our sign should be out in front, can't we? What should our sign be out in front here? Minus 1 to the third power is what? A positive or negative? Not a trick question. It's a negative, isn't it? Okay. So what I can do is I can do away with that minus 1 by simply putting a minus out in front of that thing. And I'm gonna leave everything prime factored. I'm going to be 2 to the 6th, 3 to the 3rd, a to the 6th, b to the 9th, over 3 to the 6th, a to the 15th, b to the 27th. Right? notice that base of 2 has nothing, no factor in the denominator, so it's in the numerator 2 to the 6th. Now, then you have a 3 here and a 3 base here. If you took it to the numerator, you'd have 3 to the minus 3, wouldn't you? 3 minus 6. But you can leave it in the denominator and just go what? 3 to the 3rd? Combining those two terms. Is that right? So now the A, where ultimately you're going to be with the A. In the numerator denominator when you get through adding and subtracting and doing it. Where's it going to be? Notice you have A as 15 in the denominator, 6 in the numerator. So what is it ultimately going to be? In the denominator as a what? If I took it to the numerator, this would be an A6 minus 15, right? Then I'd go A9 minus 9, and then I'd have to do what? A9 down here, right? Now then, my B, where am I going to be with it when I get all done? Where at? In the denominator with the power of 27 minus 9, right? Which is 18. Correct? In essence, what we did is what in their head. We took it in the numerator, subtracted it, and then it had a negative, we went in the denominator. We look at it, and we can say, which is bigger? Is the 9 bigger, or is the 27 bigger? It's going to end up in the denominator, right? With a positive number. We're just kind of shortcutting the process, but you know, if you had to, you could always go back and take everything out, right? Any questions on what we've done so far?
Well, that's the answer.
What's that? What'd you say?
That's all right.
Say, ask your question.
Well,
What'd you,
I was the answer, but it's,
oh, did I go too quick on you? Is this what you wanted?
yeah,
Okay. Yeah. I just didn't hear you.
yeah.
Okay. That's all right. All right, I'll do 74. So this one is going to be a minus 4 x squared y cubed squared over 2x y squared cubed. Now I'm going to take this numerator. It's going to be a minus 1 times 2 squared x squared y cubed, and it's going to be this whole thing squared. And the denominator is 2x y squared to the third. Now then, I'm going to deal with this 2. What do I do with across the top? I go a minus 1 to the what?
Where'd you get the minus 1 from?
74. It's a minus 4. So a minus 4 is a minus 1 times 4, and then that's a minus 1 times 2 squared.
Okay.
Okay? Now then, I go minus 1 squared, then I got 2 squared times 2, right? I'm putting that 2 across. X squared times 2, y cubed times 2, right? Now in the denominator, it's going to be that 2, 1 times 3, x to the 1 times 3, y squared times 3. You don't have to use all these steps if you don't want to. When I go minus 1 squared, what is that? Plus or minus? Plus. So my answer is going to be positive, right? Now then, the 2 squared in the numerator is 2 to the 4. My x, 2 times 2 in the numerator is x4. My y, 3 times 2 is 6. Now then, in the denominator, the 2 is times 3 to the power 3. X is the power 3, and y is the power 6. Now, the 2, 4 in the numerator and the 2, 3 in the denominator become what? Base is the same. The bigger number is 4 in the numerator, so we'll go 4 minus 3, right? So it's a 2. Now, the x, power of 4 in the numerator, power of 3 in the denominator, larger in the numerator, so when we take it, it's going to be what? X in the numerator. Y 6 over 6 is what? 1, right? So here's our answer right there. Correct?
What does this do?
What I want to do is I want you to take on Wednesday and tear off the front sheet. That's what's going to be due for homework. That's the only homework. When I do the quiz, 4-6, I'm going to take 2 problems off it because we reviewed 4-6 practice, right? And I'm going to take 2 problems off of this front back of this sheet. But the homework, only homework is we haven't done those scientific notations. We'll have to do that later. Any questions?